I'm hearing things. Oh, that's their average. We did a little quizzes again just to warm up the brain on trig. I think I'm live. There I am. Okay. Make all these negative just to get a better question here. So I think this really separates the difference between inverse questions and this one. We're going to do this one second. Okay, so the first one. This is the inverse rules. This is an inverse question slapped in your face right away. This is a flat out arc sine, inverse sine question. So ding, 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 ding. I got rules. I have rules I have to follow. And the rules that I said I didn't quite like, I said to you guys, but it's because of the graph and blah, blah, blah. Who cares about the because anymore? My answer must be between negative pi over 2 to pi over 2. Knowing I have a negative ratio should instantly be the negative answer. And then what is it, an over 3 or over 6? Which one is it? Over what? 6. This is a million times. Sine of a 30 equals a half. So it's the 30. 30 is over 6. Okay, and I'll zoom this out because I'm kind of like in and out of the picture there. Just like to know that you're live in class, or we are. All right, I'm going to jump to this one because this is a little bit easier. This was the point of the quizzes. I started halfway with inverse questions and then questions worded like this. All right, so then what does this entail? Well, ASTC. Where is sine negative? All students take calculus. I couldn't get that out of my head. Where's sine negative? 3 and 4. It's still the over 6's, but now I need the over 6's in 3. What is that? Blank pi over 6. What's the answer? 7. This is for those that are severely and totally behind, still not playing that game, comparing it to pi. Some people are having real problems still with the unit circle. And at this point, it is a problem. 12 pi over 6. What's backwards of that? Okay, but that's the difference between look at this answer and look at our first one. You got rules. Rules when it's an inverse question in your face. These, I told you, these are a problem. Today, these are out the door. You're doing questions like this, okay? Because either A, your rules are going to be this. That's what it means, be 0 to 2 pi, be between those, couldn't quite get that out. Or this. All right, now I am going to go to this graph, and I'm not getting real into it here. You know this is a sine graph, right? Bowl, right? And then how long does this happen? For what? Forever. So say we were going to try to do it, and I just did a real quick sketch because I don't care. I don't want to waste time on it. All right? It's not really a waste of time, though, but I just want you to understand this concept. Here's negative a half. Remember solving if we put this in a graphing calculator and found the intersection of y equals negative a half in this graph? How many times would this graph get hit? Starts with an I. Infinite. There's actually an infinite amount of answers that make this equation true. So then that's why we go to the middle and we're going to start talking about solve for all x. You know what? You're already trained for this. What is the period? What is the period of sine? What is this period? I didn't write anything there, but what is that? 2 pi, not tangents period, sines period. You did say 2 pi. So how do I get all the answers? Take those answers I just found, 7 pi over 6 from letter C, and just tack on 2 pi. I'm going to do n, even though in our notes later it says k. And then NEZ, n is an element of integers. All right. And then the reason it's got to separate these two is because these two are not linked together very nicely. 7 pi over 6 and 11 pi over 6. Someone in my second hour, even though others in my second hour may be infuriated. A, they can't plug in their Chromebook overnight. B, they can't come to school. I had 5 absences out of 19 students. That's a significant percentage. Anyway, let's get over that, Mr. Samuelis. But someone in second hour asked a nice question about could I tie these two together in one answer? And you can't. 7 pi over 6 is here. 11 pi over 6 is here. They don't connect equally this way to that way. So you got to separate them into two separate 2 pi n things. Tangent is different. So now I'm going to go to this. Here's another solve. This is in quadrant 1. So all it did is change the over 6s to these, but then notice 2 pi k. Where k is an integer, we say KEZ, so we don't have to write all that stuff, right? Right. Okay, but then cosine, same thing. The period of these two are 2 pi, so to name all the answers, we tack on a 2 pi k or a 2 pi n, and we're good. Same thing with cosine. Pi over 3 and 5 pi over 3 are here and here. I can't tie those together by generating them in one answer. I have to separate them into two answers. I hope you kind of know what I'm talking about there. You really understand it with tangent. What's the period of tangent, everybody? What's the period of tangent? Pi. So where do you get tan of x equals 1? You get that at the 45s, pi over 4, but then also 5 pi over 4, because that's negative 1 over negative 1, which is 1. How far away are these answers away from each other? All the way around, there to there and there to there. Pi. So that is why this gets one answer, but it's also because the tack on for the integer generation of the answers is pi k or pi n instead of 2 pi, but really it's because the period of tangent's pi anyway. So that's another reason for it. So always with tangent, to write all solutions, you could get them in one answer because the period is pi. So I want you to recognize those differences there. That's really the only hard part today. But for us, it shouldn't be hard because I've been doing this with you for a while. This whole pi or 2 pi n element of z. And we also did asymptotes with tangent with the same terminology. All right. I like how this one's worded because this can really help somebody that is a little bit behind. But you still have to have something memorized, like this triangle. This is what I made my students do last year. It was always triangles. 30, 60, 90, those sides. So this is y over x, right? Ticks, right. So the reference angle is opposite 1. This is what I was trying to hammer. So what is this, a 30 or a 60? 30 or a 60 reference angle? 30. Look at the triangle over there. 1's the smallest side, 30 is the smallest angle. All right, so this is a 30. This is an over 6. So x equals, well, it's positive. So it's pi over 6 and 7 pi over 6. That's the quadrant 3 answer. All students take calculus. And that's why I'm able to do this in one answer, because quadrant 1 and 3 are pi away from each other. So all solutions would just be pi. I'm going to use n. I don't care. My k's look like x's, and I just want that to look better. So it said all solutions. Now, if I plug in 1 for n, then I get this answer. I do get 7 pi over 6. 1 pi is 6 pi over 6. 6 pi over 6 plus pi over 6 is 7 pi over 6. So I want you to know that does generate the third quadrant answer. Then if I plug in 2, I'm back here. That's just more than one revolution. If I plug in negative 1, I believe I'm over here in quadrant 3 again, and so on and so on and so forth. All right, and then another find all solutions. Right, this is a little different, though. We have cosine. By the way, as soon as you see root 2 over 2, what is it? Over 4, over 6, or over 3? If you don't know it's an over 4, get out. At this point, root 2 over 2, how many times we've covered this? Yes, I mean. All right, and then where's cosine negative? Where's cosine negative? What quadrants? 2 and 3. Here's a problem with 2 and 3. These angles are different, compared to where they are to each other before and after. I can't put this as one answer. All right, and then what do I put here is 4 pi over 4 for those that are severely and totally behind. So x is equal to the backwards one, 3 pi over 4. And then the period of cosine's 2 pi. So for all solutions, 2 pi. Whoops! I threw k in there, so let's stick with k because it doesn't matter. You want to put n, you put n. I don't care. Doesn't matter as long as you have some sort of variable. See, I really hate that k, though. It does kind of look x-like. And then what's the one in quadrant 3? forwards pi over 4. Same generator on there. K is an element of integers. K-E-Z. Okay? So that's all. All, and all. Got another all coming up here. Okay, and then circle that up. Again, the period of cosine is 2 pi. So just tacking 2 pi's on should be fine for all solutions. All right, just stalling for those that were still writing. Okay, and then again, find all. So we're really hitting this all thing down. Read your directions, though. Your homework is a little bit more straightforward. By the way, your homework has got a lot of questions because they should be fast. They really should be. All right, based off of that quizzes and getting you to get this unit circle down. I gave this to my Math 2 honors people too, and some people shut down. But what do you simply got to do to get this ready? To get this ready to solve? Anyone? Divide. Okay, and then this becomes sine of theta equals, okay, that's root 3 over 2. That's root 3 over 2. That's easy. What is that, an over 4 or an over 6? It's one or the other. Which one is it? I'm sorry, wrong. An over 3, that's why you're looking at me weird. An over 3 or an over 6? Which one is it? It's an over 3 because the over 6 is our half. Sine of a 30 is a half, so this is sine of a 60. A 60 is an over 3. And then where is sine positive? What quadrants? ASTC, which quadrants? 1 and 2. So I have the over 3s in 1 and the over 3 in 2. So x equals, no, it's actually theta. Caught myself. Theta equals, and then these are not equidistant away from each other, moving around the unit circle. So that's the argument of just 2 pi. Let's go back to n. K. Make up your mind, Mr. Samuels. All right. Accidentally did K in the last one. I don't like K. I don't like it. Okay. That's it. Okay, circle it up. AP time. Oh boy, it's a sentence. Makes me read. Stupid. I heard someone say that. We're anti. You didn't say stupid? Oh, someone's poking someone. Oh, this is actually high school, but this is what happens in America. Pokey. All right. They're still arguing. Let f of x equal this. Let g of x equal this. In an xy plane, what are the x coordinates of the points of intersection of the graphs f and g? Really, this is all they mean. What is the solution when this equals this? So that's what we're going to do. We are certainly not going to go to the graphing calculator and try to solve this on that. Didn't really do a lot with graphing on the graphing calculator. We did when we were doing regressions and then solving from it. You know, we had to set up the calculator and all that. Takes a lot of time. It would be a waste. If we just understand the reading of the question, this is what it's asking. All right. First thing is to do what? Anyone subtract? Got to get them started. And then that's -1. Then the next thing is what? Divide. Got to get them started. And then here we go. And then what? What are the directions? Now we're back to from 0 to 2 pi. I only want the answers in a unit circle, 1 revolution. Where's cosine negative? What quadrants? What quadrants cosine negative? Same questions we had before. 2 and 3. So I need the 2 and the 3 answer. And that's it. I'm done. Cosine of who is a half? Is it over 6 or over 3? 3, 2, 1, go. It is over 3 because sine of an over 6 is a half. So cosine of an over 3 is a half. I don't know how we're going to get people to get this down. We're trying. Go backwards, go forwards. We're trying to get everyone on the same page. Okay? I don't know what it's going to take to get everyone on the same page of knowing these ratios. All right, blah, blah, blah. You can read all that stuff. Fine and great. I want to get to the brass tacks of this. I want to be just like your homework. If I would have done the notes, it would have just been like that. I do like the graphing thing to understand why it's all solutions. or why we get so many of them. But this is important, a mathematical symbolism. Mathematicians are lazy. That's why they come up with symbols so they don't have to write out words. So one thing that they do, they just put sine squared of x. Crinkle, crinkle. And then that means that set of parentheses squared. So we're going to do two things on this one. What do we want to do first in this one to solve? What do we want to do? Divide. But then I'm going to write this. I got to get them started. I'm going to write this as they're saying. This means the same thing as cosine of x squared. That's how this, they're just being lazy, so they don't have to write those brackets. You don't have to write it like that. Yeah, I'm just making a point. And then that equals a fourth. And then what do? How do you get rid of squaring? I almost said it. How do you get rid of squaring? Square root. So now you're going to root both sides. And then I've told you this, but unfortunately it probably hasn't been since September maybe. When I square root both sides, what do you got to do to the right side? Got to get them started. Plus or minus. And the square root of 4 is 2 for gosh golly sakes. So it's 1/2. Okay, I wish this didn't say all solutions, because then this would be kind of neat. But I'm glad it does, I guess, in a way. Then this is where the second hour student asked a really good question, and I'll cover that. Okay, but this is what's great about plus minus. Where's cosine positive? Where's cosine positive? I'll highlight it. 1 and 4. Where's cosine negative? I'll highlight that. 2 and 3. So guess what it covers? 1, 2, 3, 4. It covers all 4 quadrants. So even if you made a mistake on which quadrant was positive and negative, you just have all 4 angles anyway. And what is it? It's an over 3 or an over 6. We just had this. It's an over 3. If you missed that, you'd make me really sad. Oh, by the way, it's an over 3, but now we got something special here. This is 4 pi over 3. I put these two here on purpose because tell me, how far are those away from each other, are they? Pi. I have to do all solutions. So what I could do is take x and set it equal to pi over 3, and then just listen. Again, this is for the half list. This is why I can't stand people with their dang phones. I so wanted to swear right there because they're always like, oh, he's not looking. All right, and then they get on their phone real quick and see what they got, and then they don't listen to me. All right, so back to this. I'm okay. These are pi away from each other. So this is a little special condition. Special. I can name those together in one little chunk because they are pi away from each other. And then x equals, this one's 2 pi over 3, which is not, these are not the same. This distance is not the same as that. That's what the question was. A good question from second hour. Really good. All right. But 2 pi over 3 to 5 pi over 3, guess how far they are away from each other. Now, the people that are jim-jacking around on their phones, half listening, will ask me, how come he didn't write 4 pi over 3 in the answers? And I'm just going to go crazy. I'm going to go nuts. It's just literally going to go nuts. So we got to get, that, I don't want to say common sense, but just kind of figuring out. Now, I will say this. If you put x equals pi over 3 plus 2 pi n, x equals 2 pi over 3 plus 2 pi n, 4 pi over 3 plus 2 pi n, and 5 pi over 3 plus 2 pi n, I don't know if AP would mark you wrong. All right? I don't know if they would, because it's technically not wrong. You just wrote too much, is the best way to say that. All right, we'll move on. I think I made a good point there. Now, write this down. Here's what I'm going to see a lot of people do. And then go ahead and do this right now. That is the worst thing you could ever do in solving an equation. You never, ever, 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 ever divide by a variable when you're solving an equation. Ever. You lose a whole set of answers. So I want that written down there so I do not see that mistake on a test. So what do? You got to get into a format of factoring. You got to get this into a factorable situation. So you go ahead and add sign to both sides. All right, so again, this is why I'm like rolling through factoring because I am 2 honors. We talk about factoring a lot. It comes up. Unfortunately, in the AP curriculum, they don't bring up factoring enough. All right, and then we haven't done this probably since September or October. All right, so what is the first thing you got to remember about factoring? What is the first easy way of factoring? What could you take out? I got to get them started. GCF. See, it always gets them started. And the GCF is a sine. You got to treat sine, cosine, tangent like variables. X, Y, Z. They both have a sign in them, sine squared and sine, so I can undistribute a sign. Good foiler, say it. That's actually false on this one, though. It's good distributors are, say it, good factors, because this is the reverse of distribution. If I throw that back in, of course, this is true. Makes sense. And now what we got to use is what's called the zero product property. Now, again, you did this too much in Math 3. I'm from Math 2. Too much in Math 2 to not remember this. And then I'm going to go a little faster here. When I said sine of theta plus 1 equal to 0, I subtract 1. Okay, subtract 1. So that's what those two zero product properties end up becoming. And then this is why I did the quiz is. The quiz is hammered down the point that this is 0 over 1, y is 0, r is 1. That means x could be plus or minus 1. And notice it says find all solutions. But let's list the ones that we know and then figure out what we can do to get this tied together in an all thing. Where do you get y is 0 and x is 1? Or better said, where's 1 comma 0? Which way do I go? Which 1 comma 0? Which way do I go? Right. What is that angle measure? 0. What's negative 1 comma 0 though? What's that one? Pi. So the answers before all solutions are 0 and pi. How far away are those answers, guys? How far are they away? Pi. So all answers is, you know what you can simply do? Pi n, because n could be 0. And therefore, if I plugged in 0, I would get 0. But then I could plug in 1 and get 1 pi. I could plug in 2 and get 2 pi, which is the same spot as 0. This is how this generates all the answers on if you saw a graph of sine. All right, and then negative 1 over 1. Where do you get x is 0 and y is negative 1? Where do you get that? Because we weren't too good on this on the quiz is. Where's 0 comma negative 1, everyone? Up, down, which one is it? No, 0 comma negative 1 is down. What does that angle measure? Mr. Wilson brought up a great point, by the way. Could you, in this answer, could you put negative pi over 2? And the answer is yes, because you just need one of them and then generate the rest of them. So he asked me that in the hall, like just making sure. And there's no way we could mark you wrong in this if you put negative pi over 2, because that is one of the answers. If I plug in negative 1, you get negative pi over 2. So yes, all you need is a starting point and then the 2 pi n to generate the rest of them. There's no hard rules on that. But there are hard rules when it says 0 to pi or 0 to 2 pi. Then you got to answer a positive within one rotation of a coordinate plane. I only got 2 more. I know it seems like a lot, but there really isn't much new here. All right. If you're struggling on the 0 and the pi and the 3 pi over 2, you're behind. All right. We got to be able to come up with those answers. You don't have to be doing them in 5 seconds, but you have to be figuring them out in 20 seconds by doing what I do here, doing a little rationalization, a little figuring it out kind of thing. Cirkicks or tixing. All right, and then there we go, AP. Let F equal this, let G equal this, XY plane. What are the X coordinates for the intersection of? It just means what happens when these two are equal. What do you get for X? So that's what I'm going to do. All right, now, good foiler, say it. We haven't done this in forever. I think the A people think you are professional factors. Sorry, here's a typical Samuelus shot. I know the truth. I've seen it. We already had tests on tried to factor for like a month and a half. That was August and September. And still walked out of that with people unable to factor. I think we did a little bit of factoring later, like maybe in January or December. So I remember I threw a factoring sheet at you again just to make sure we knew how to factor in a certain scenario. Oh, we were doing rational functions. Absolutely. Absolutely. Okay, the first thing we're going to do is subtract, but it's been a while. Subtract cosine is the point of that. We haven't factored in too long. -1 from 4, that's +3. So we got to remember when you're solving a quadratic, we got to get it equal to 0. So I subtracted 1 and subtracted cosine like a variable. Okay. Now, what if it's not factorable? What song did we all sing together? The opposite of b plus or minus the square b squared minus 4ac all over 2. Okay. All right. So we actually did do that with our team of students last year. If this was not factorable, you'd have to put a is 2, b is -7, 3 is c, get that decimal, and then that's what cosine of theta would equal. And you would get two answers, a plus and a minus. All right? All right. Oh, I'm running out of time. Okay, so I was wondering why these people are all fidgety over here. All right? All right. Now, unfoil. First of all, this kills me. This is why I said good foilers are good factorers. These numbers right here have to multiply by to be 3. What's the only thing that multiplies to be 3? 1 and 3. Look at the middle term, though. It's negative. So it's got to be -1 and -3 because I still need a positive product. It's the only way I could get a negative middle term. Next thing is cosine times cosine is cosine squared. So that's why this still works. Cosine theta, those multiplied together are cosine squared. One of them have to have a 2 on it, though. Okay, because 2 cosine times 1 cosine is 2 cosine squared. Which one gets the 2? The first one or the second one? That's when you do this. Is it the first one or the second one? 3, 2, 1, go. First one, for gosh golly sakes. Because 2 cosine times -3 is -6 cosine. And then 1 cosine negative is -7 cosine all put together. Now, zero product property, as I see we're falling short on time. Add 1, divide by 2. I should not have to teach that. Set this equal to 0, then add 1, divide by 2. And then weirdly, the other one, I add 3 to both sides. Something wrong. Because how could the adjacent side be bigger than the hypotenuse? Is that possible? Where did you get that from, by the way? Ka. I just wanted to go to ka. But x and r, there's no way x is bigger than r. So this doesn't result in real or answers. That's just not possible. And then where do we get, and this is from 0 to 2 pi, where do we get 1/2? What kind of, is it an over 6 or an over 3? It's an over 3. It's in 1 and 4. So it's pi over 3 under these directions, and then 5 pi over 3. And that's what we get. All right, last one because of time. 0 to 2 pi. But wait a minute. When I subtract 2 and divide by 7, is -2/7 a ratio on our unit circle? Yes or no? Calculator. Here's the problem with the calculator. Problem with the calculator is your answer is going to be a decimal. So I want to remind my students that this is 0. This is 3.14, right? Pi. This is 1.57. And this is 4.71. Before I continue, where's sign negative? What quadrants? What quadrants? 3 and 4. That means your answers, oh, by the way, I got to add one more, 6.28, right? 2 pi. That means one of your answers should be between 3.14 and 4.71. And one of your answers should be between 4.71 and 6.28. The problem, as you put your papers away, is when you go to inverse sine -2/7, you get -0.289. So all I have to share with you as I move my fat head out of the way is that is a reference angle. So here's 6.289 dot, 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 dot. How do I name this way? 6.28 minus 2.289. And then how do I name this way? 3.14 plus that reference angle, negative 0.28, actually should make it a positive. So there's where I have those answers. I stored negative 0.28 in for x. Then I added that negative to 2 pi. 5.99 makes sense. And then I subtracted it from pi because it's a negative value here. 3.43 is between 3.14 and 4.71. Movie over. Doink.